All right, everybody. Today we're going to be leveling up some of our Linux skills. And this begins with an understanding of something called streams. See, in Linux, data is essentially streamed throughout the entire machine. So, for example, the term stream actually refers to something that can transfer data. Now, Linux provides three of these: StdIn, StdOut, StdErr. We, as Linux users, can actually manipulate these streams and use them to more or less better define commands in order to give us the appropriate outputs that we desire. We're going to talk about this and more. My name is Tim Patrick. This is Alta3. Let's break it down. All right, everyone, before we get started with putting in our commands, let's go ahead and define some terms. As we stated at the beginning, a stream is something that refers to the transfer of data. Linux has three different streams: StdIn, StdOut, and StdErr. And just for the sake of helping give a bit of a visual aid here, we're going to break each of these streams down one by one so we know exactly what it is we're talking about. So the first stream we need to talk about is standard input. This is text input used to give a command, provide arguments and parameters. Essentially, this is what we are sending to the machine. However, it can actually get a bit more involved than that. Let's continue. The next thing we need to talk about is standard output. Okay? And as you might have already surmised, this is essentially text output from the command to the shell, or really to what we see, or whatever program is taking that standard out and manipulating it even further would see. This is text output from the command. All right. And then finally, we need to talk about StdErr. Now, StdErr are error messages. Okay. And these are error messages that might be generated by running a command that is unable to complete cleanly. There's an error, something happened, and Linux will give us data. It'll give us the stream of what it thinks happened, why it didn't work. That's StdErr. And the cool thing is that in Linux, each of these have sort of its own number assigned to it. It's a zero-based system. So the first one would be StdIn, and that is assigned the number 0. So when we want to see StdIn, we can make a call to 0. StdOut would be 1. And finally, error would be 2. StdErr would be 2. And we're actually going to see how these are used in commands later on in our lab. But just to get started, we now have our terms defined, both how we understand it and how Linux understands it. Let's go ahead and distinguish the difference through examples of what a StdIn, StdOut, and StdErr really is. So we'll begin with a simple command, and that command is simply read. At this point, Linux is expecting input from me. So input would be my standard input. But in short, what I just sent Linux by typing input and hitting return would be StdIn. I gave it input in text. Now, I gave it no way to interpret the text or anything to do with that text, but it was still captured as StdIn. Next, let's go ahead and see what an example of StdOut might look like. So we'll do ls-tach-l. And here you could see that I am given a list of various files that are within this particular directory being home student here in our beachhead learning environments that Alta3 provides its students. We'll go ahead and clear that out and continue on. So ls-tach-l provided for us an output, that being our directory, the files that were within it. That was an out. Awesome. So now we kind of get an idea, okay, things that I give Linux, that's input. Things that Linux gives me, that's output. All right, cool. Now, what about error? Well, we could do lstech-l anything. And you'll see that Linux cannot access anything because there is no such file or directory. We know that's an error because anything simply does not exist. If we were to make anything into something just simply by touching anything, this means create a file. If I were now to type lstech-l anything, you'll see that we actually get a response because that error is no longer a thing. Anything exists. Now, for the sake of our examples, we'll go ahead and remove anything and we'll clear this out. But that's the idea. That is standard error whenever we get an error message from Linux, okay? So let's go ahead and start talking about the idea of redirects or piping in Linux. You see, standard input could have originated as standard out. We could take standard out of a result of a command and treat it as input for another command. So for example, we can run echo good morning. Give it a nice exclamation point, and then we're going to use a pipe. You can use a pipe by hitting Shift / actually, I think that's backslash. I always get those confused, guys. Let me know. But essentially, it's the key above the Enter key, all right? In any case, guys, look, sometimes I forget little things. This is one of them. But yes, you execute a pipe that way, and this creates essentially an instruction to Linux to take my input and give the output based on the command that I gave. In this case, echo good morning, in which case Linux would just simply return the string value good morning. But I want it to send that good morning to another command. In this case, we want to use grep, and we want to grep on morning. Now what grep does is, I usually like to call it like a get. It shows us, it gets something from an input, right? In this case, it's getting morning. That's what I told it to go and get. So we took the command echo good morning, and then we said we want you to grep one of those words, in this case morning, and we see the grep return. This is actually the return of the command grep. That's the standard out of that command grep. We took our standard in echo good morning. Linux then generated an output, which was good morning, exclamation point, which then took that standard out, used it as input into the command grep, where we grepped for morning. So we were able to redirect that input to another command. Neat, really fun, really easy. And now when we start thinking about Linux in this way, that we could take these different streams of data and manipulate them and change them and play around with them and put them into different commands, suddenly the potential kind of becomes very real in our minds. Instead of relying on an application to manipulate our file system for us, we are able to do that ourselves. We don't need an application to perform more complicated functions. We could just write a simple Linux command and expect output. How awesome is that? But we got a few more examples for you, so we'll go ahead and continue. So now we're going to go ahead and run the command echo good morning. And we're going to use the pipe again, but we're also going to use the and symbol. Now, what this is going to do is it's going to send the standard out and the standard error to our grep morning command, or maybe we should try something different. Maybe we should just simply try a cat command. See what we get. We just get good morning. So we sent that standard in to cat command, and we got a return good morning. There was no error there, but if we wanted to see both, that would work. If we wanted to send both, I should say, the standard in and the standard error to the next command, pipe and symbol, that would send both. Awesome. So we'll go ahead and do the same thing here. And we're going to actually get an error. We're going to use pipe and space cat. And what we actually get is a cat of the standard error of the anything command. In this case, anything isn't a command. It's not found. Linux really didn't know what to do with it. It created a standard error. And in that standard error, it sent it to cat, and cat returned the error. Neat. How about that? Now we could do some other fun things with redirects. In this particular case, we're going to go ahead and continue our good morning routine here. And we're going to send good morning txt, the greeting txt. So essentially, we're saying echo good morning, and we want you to write the standard in on the file greeting.txt. And you'll notice here that greeting.txt has been created for us. It didn't exist before. And it has the standard input that we gave in the first part of our command. Now, let's go ahead and use the same exact command, but this time we're going to say good evening. And we'll add that into greeting.txt. And now we'll go ahead and cat it. Now I'm kind of wondering, how many of you all know what's going to happen here? Good evening. The single greater than symbol will overwrite a file. Kind of need to be careful here. If you instead want to add to the end of an existing file, right? We would use two greater than symbols. So we would do echo good night. Greeting.txt. Now we'll go ahead and cat greeting. And we have good evening and good night. So be very careful when using a single greater than symbol, unless it is your intention to completely overwrite a file if it already exists. You might instead be better served by using two, okay? So what you're seeing here is that we are writing a command, providing input. Linux generates standard out. We then take that standard out and use it as a input for another command. In this particular case, writing to or overwriting a file. We are taking standard out as a data stream and continuing to use that information to make changes to our file system, to make changes to an application or a file, or to perhaps maybe even grep information from that standard in, standard out. Really cool stuff. Let's keep on going. So now let's do something a touch more complicated. And this is going to involve a Python script. Hope you guys are excited about it. I like to write Python from time to time, though granted, I don't have as much time to do it as I'd like these days. So I figured, why not go ahead and sharpen our skills, or at least stay within the know, even just a little bit. And let's get into some Python, shall we? So we're just going to go ahead and create a file here called Python StdIn.py. And we're going to do a couple things here. We're going to create two variables, name and email, and we're going to be looking for an input here. We're going to be looking for an input for enter name, and we'll go ahead just to kind of keep some nice clean formatting. And we're also going to be looking for an input enter email address. And we'll go ahead and do that. Beautiful. And then we're going to print the result. Okay, we're going to print your name is, and we'll just throw in a couple things here, and email is that equals name email. Beautiful. And close that out, nice and neat. And we'll go ahead and write quit. And now we have Python StdIn. Awesome. So now that our Python script is done, we're going to go ahead and try out something a little new. What we're going to do now is we're actually going to go ahead and send data from a file into our Python script. We could do Python 3, Python StdIn, and this time we're going to go ahead and use a less than symbol. And we're going to use the less than symbol for greeting.txt. And you could see that it actually provided those inputs, good evening and good night, into those two variables. So your name is good evening, and your email is good night. Nice. That's kind of cool. You can imagine how you could take a standard form now and actually start manipulating that data in intelligent ways with simple Linux commands. Okay, so here's the crazier part. We could do this as many times as we want. So let's go ahead and run the same command again, but this time we are also going to use the greater than symbol to write the standard out to a text document called output.txt. Output.txt didn't exist before, so we'll go ahead and take a look and see how this goes. And what do you know, when we cat output.txt, we see that your name is good evening and email is good night. How cool is that? So now that we've gone all the way through this, had ourselves a little bit of fun, we still got a little bit more of a ways to go. Because we also can do the same thing with StdErr. So we can generate an error and actually write the StdErr to a file. Remember how I mentioned that StdIn is assigned the number 0, StdOut is assigned the number 1, and StdErr is assigned the number 2? Well, this is where that kind of comes into play. We can generate an error by trying to run the command anything. Well, that no such command exists. This command would not work. In fact, if we just did that, we would get anything command not found. So what we'll do instead is we'll do anything, but we're going to write a 2 and then the greater than symbol. And like send it this way, send the standard output over here as input, right? And we're going to go ahead and we're going to send it to error.txt. Now, if we cat error.txt, we actually see the error, anything, command not found. Now, this is pretty cool because essentially this is enabling us to generate essentially log files. Imagine that you have a standard out that is producing both valid entries that you care about, but also it's producing StdErr. You want to catch these errors, but separate it from the nice, clean return that you're expecting, right? Well, we can now do that using a Linux command to greater than or StdErr send to, as I like to see it. How cool is that? So now, not only are we able to understand the difference between StdIn, StdOut, StdErr, we're now able to actually take standard outputs, turn them into inputs, put them through other commands, write them to files, and do all sorts of fun, powerful things. And you can do this with pretty much any Linux command. Pretty neat. Still not quite done yet. So we're going to go ahead and write echo, good morning. And we want to send the standard output to the output.log. Now remember, we only used one greater than symbol, so that means that it will overwrite output.log. That's fine. That's expected behavior for us. And we're going to do the same thing over here. We're going to do 2 and to debug.log. And now, if we cat output we see good morning. And if we cat debug.log, we'll see that there was nothing. That particular command did not generate an error. Okay. Guys, this is really simple StdIn, StdOut, redirect piping instruction for Linux. We offer all sorts of really cool Linux instruction here at Alta3, and if you'd like to participate in that, be sure to check out our website. That is in the description down below. In any case, though, if you have any specific questions for me or any of the other instructors here at Alta3, feel free to come on by and join us in our Discord community hub. The link is also there in the description down below, and you can stop by and ask us any number of questions, maybe even take a look at a more organized version of our video catalog, and maybe even catch up on some other training that you can get on our YouTube channel for completely free. In any case, guys, thank you so much for watching. My name is Tim Patrick. This is Alta3, and see you guys next time. Have a good one.
This video was brought to you by Alta3 Research. We offer training solutions both on-site and online, so you can choose the method that works best for you. If you liked the video, check out the links in the description box below for more information on our course offerings. Please like, subscribe, and hit the notification bell below to see more videos just like this one. Thanks for watching, and see you next time.